Hello, my name is Mackenzie Champion and we will be discussing inverse variations. So, inverse variations, two variables x and y show inverse variation when they are related as follows. Y equals a over x and a cannot equal 0. The constant a is the constant of variation and y is said to vary inversely with x. And these equations are pretty simple. You just have to follow the equation given and just input the points or find whatever you need to find. So, in our first example, we are going to be classifying equations, and we are going to tell whether or not the following equations are direct, indirect, or neither of them. And we will see a couple of indirect ones, and we'll be using our inverse equation as well. So, for our first one is x times y equals 7. For our second one, we have y equals x minus 3. And for our final one, we have y divided by x equals 6. So for our first one, we are going to divide both sides by x. And that will cancel out the x on one side, and then we will get... So these are pretty simple, and then we will get y equals 7 divided by x, which is an inverse equation since it's the same format as our inverse equations, and you'll see a pattern eventually. So for our next one, since the y is already by itself and you can't divide or multiply either the sides, this indicates it's a neither equation. So this shows like a different kind of pattern, so you just have to remember like if it's being added or subtracted, it's neither. For our final one, we will be looking at y divided by 6 equals x, and you just multiply both sides by x, and you get y equals 6x, which shows a direct equation. And it's pretty simple. You just gotta make sure you're looking at the problems. You can kind of see a pattern in most of them, so you just have to watch out for those. So for example 2, we will be classifying data. So we are going to have a table. So on the top we have 2, 4, 6, and 8 for x, and on the bottom we have -12, -6, -4, and -3. And what we'll be looking for is to see whether or not these equations show indirect or direct equations. So we're going to find the products x and y and the ratios x divided by y. And if the products are x, y, and they're all the same, that means it is a direct, and if the ratios are the same, that means it's an inverse equation, an inverse equation. So here we have our table. We have x and y on the first row and x divided by y on the second row. And by multiplying the top two, we get all -24, which indicates a direct variation, but it's always important to check to see whether or not the bottom shows if it's an indirect or a direct, or a direct or indirect. Yeah, inverse, that's what I'm looking for. And as you can see that none of the bottom ones are the same number, so that indicates that this specific equation is a direct equation based on the first row being the same. So example 3, writing an inverse equation. The variables x and y vary inversely, and then when x equals 6, write an equation that relates x and y, and then find y when x equals -2. So what you want to do is basically we're gonna go back to that first equation we saw, y equals a over x, and plug in the values that we got earlier to find the equation. So what we're gonna do is we are gonna replace the y with the 8 and the x with the 6, and you're gonna cross multiply or multiply both sides by 6 to cancel on one side, and then you get a equals 48, or 48 equals a, And now that we have this value, we will be finding whether or not, or what y equals when x is negative 2. So we want to take the original equation and replace the a with the 48. And now we're going to replace the negative, or excuse me, the x with the negative 2. And then you will be dividing the 48 by the negative 2. And then you find that when x equals 2, y equals negative 24. Alright, thanks for watching. Thank you.